this session, we are going to discuss about DC transient in RC circuits. First of all, let's see this problem. Find the transient current and voltage across R and C after switch is closed at t is equal to 0. Neglect initial condition. This is the circuit. Here we can have a DC voltage source having value 10 volt. And the resistance value is 3K and the capacitor value is 100 microfarad. So whenever this switch is getting closed at t is equal to 0, current I of t will flow through the circuit. In order to solve this transient problem, it is easier to convert this network into S-domain network like this. This 10 volt become 10 by S. And there is no change for resistance, and corresponding to capacitance, the impedance form is 1 by ESC or CS, so it become 1 by ES into 100 micro. Now we can easily find out the KVL equation over here. The KVL equation, after simplification, we can write I of S into the total impedance is equal to 10 by S. That is I of S into 3K plus 1 by S into 100 micro is equal to 10 by S. After simplifying, we can obtain I of S as 3.33 into 10 raised to minus 3 all divided by S plus 3.33. Now we can easily find out L inverse in order to find out this I of t. I of t can be obtained as 3.33 into 10 raised to minus 3 e raised to minus 3.33 t. Alternatively, we can find the expression for this current from this generic equation which we derived in theory session. That is I of t is equal to V by R e raised to minus t by tau, where tau is the time constant of the circuit. In RC circuit, the time constant is RC. So RC can be obtained as 0.3 second. So after substituting V, R and tau in this equation, we can obtain I of t as 3.33 into 10 raised to minus 3 e raised to minus 3.33 t ampere. Suppose if the question is mentioned to calculate VR and VC, voltage across resistor and voltage across capacitor, and to plot these variation with respect to time, then first of all we need to calculate VR, then VC, and substituting different times we need to find the value of VR and VC, and then we need to plot. So let's see that one, even though it is not mentioned in this question. So voltage across the resistor is I into R. So I is obtained as 3.33 into 10 raised to minus 3 e raised to minus 3.33 t, and R is 3K, that is 3000. Substituting these values, we can obtain VR as 10 into e raised to minus 3.33 t volt. As we know, in this KVL equation is satisfying after switch is getting closed. So 10 volt is equal to the sum of these voltage, that is voltage across the resistor and voltage across capacitor. So from that concept we can find out VC as this voltage minus voltage drop across resistor. That is VC is equal to V minus VR. V is 10 volt and VR is obtained as 10 into e raised to minus 3.33 t volt. So after simplification, we can obtain VC as 10 into 1 minus e raised to minus 3.33 t volt. Now we can substitute different value of time 0, tau and infinity in these two equations, that is 10 into e raised to minus 3.33 t volt and 10 into 1 minus e raised to minus 3.33 volt. So VR corresponding to 0 time is 10 volt. And corresponding to tau, its value is obtained as 3.678 and corresponding to infinity it's 0. Similarly for capacitor, corresponding to 0, its value is obtained as 0. Then corresponding to tau, its value is 6.32, and finally for infinity, its value is 10. So corresponding to these values, we can plot this curve, that is graph. So from this graph it is clear that VR is exponentially decaying and VC is exponentially rising characteristics. So corresponding to t is equal to 0, VR is equal to 10 volt. Corresponding to tau, its value is 3.678 volt. And corresponding to infinity, its value is 0. So we can obtain VR as an exponential decaying curve. Similarly, we can obtain an exponential rising curve for VC, voltage across capacitor. So as t tend to infinity, voltage across the resistor becomes 0 and voltage across the capacitor become 10 volt. As t tend to infinity for DC circuit, capacitor act as open circuit. So the voltage remains constant, so there is no current.